two masses m1 and m2 are tied between by a rope parallel to the inclined plane surface as shown in figure. Okay, so the two masses is tied between the rope. Okay, rope. So the masses are 22.5 kg and 14 kg respectively. Okay, the coefficient of friction between m1 and plane is 0.25, while the mass of m2 and plane is 0.025, sorry, 0.5. This is mass m1. Okay, so m1 is 22.5, this is m1, this is m2. So coefficient of friction between mass and plane for m1 is 0.25, m2 and plane is 0.5. To find the inclination of the plane surface, okay, that is theta, which the masses will just start sliding. Okay, ஸோ என்ன பண்ணணும், இந்த தீட்டா ஃபைண்ட் அவுட் பண்ணணும், எந்த தீட்டா ஆங்கிளில் இந்த மாசஸ் வந்து ஸ்லைடிங் ஆகும் கீழே அப்படிங்கிறத ஃபைண்ட் அவுட் பண்ணணும். சரி, தட் இஸ் த finding. Then next one, to find the tension in the rope, T value. So T and theta, we want to find the T and theta value. Okay, so first this is mass m1 and mass m2. So free body diagram of this is a mass m1 of 22.5 kg, this is mass m2, this is the 14 kg. Okay, so first to draw the free body diagram of mass m1. Okay, this is the inclined mass. Okay, m1 is the 22.5 kg. Okay, is the inclined surface, this is the inclined surface of mass m1. Okay, is the parallel and horizontal line of mass m1. Okay, so mass is acting, okay, is a 22.5 kg. Okay, so 22.5 into 9.81, so mass acting into vertically. Okay, this is the mass acting vertically, this is a 22.5 into 9.81 kg, 9. Newton. Okay, this is a Newton, is the mass. The next, reaction force acting in the vertically, okay, perpendicular to the masses, is the reaction force Rn1. Okay, so tensile force, okay, acting this direction T. Okay, then frictional force is acting this direction. Okay, F1 is a frictional force of mass 1. Then component force, okay, this is the mass and this is the angle, this is the theta. Okay, so we want find the component force is the reactions. Okay, this is the and clockwise direction, so component force in the anti-clockwise direction. Okay, anti-clockwise direction. Okay, this is the mass 22.598 kg, 981 Newton act out. This is the mass of block. Okay, is the incline to the mass. So this component force, okay, this is the clockwise, reacting in the clockwise, the component force in the anti-clockwise direction. Okay, this is the anti-clockwise direction, so this direction and this direction. Okay, is the theta opposite side. Okay, is a 220, so 22.5 9.18 is 220.725 sin theta opposite side, so adjacent side is 220.725 cos theta. Okay, so next, free body diagram of mass m2 is a 14 kg. Okay, so 14 kg is 130, 14 into 9.18 is 137.34 Newton acting vertically. So reaction force, okay, reaction force is perpendicular to the block, so is Rn2. So frictional force is, okay, it's a tensile, is the frictional tensile. Okay, opposite to the frictional force, opposite to the tensile, say F2 frictional force. Okay, the frictional forces restrict the moment of the block downward. Okay, is the clockwise direction, reaction force is the force, so 137.34 is the clockwise direction, so component force in the anti-clockwise direction 137.4, so sin theta opposite side sin theta, adjacent side is cos theta 137.34 cos theta. Okay, this is the free body diagram of two blocks. Okay, so this is the free body diagram of mass m1. Okay, mass m1. Okay, so 220 point, so is the weight of the mass, okay, 22.5 kg, so 22.5 into 9.8 is 220.725 sin theta. Another one is the cos theta component force, okay. This is the tension, is the reaction force and the frictional force, okay. Is the frictional, so reaction force is perpendicular to the block act ஆகும். This is the reaction force is the block வந்து பண்ணுவோம் கீழே ரெஸ்ட் வரதை ரெஸ்ட்ரிக்ட் பண்ண the frictional force to find the angle, okay. So first the sum of vertical forces is equal to 0. So vertical forces another Rn1 and 22.75 is the vertical force, both are vertical force. So Rn1 is equal to 220.75 cos theta, okay, Newton. So next the frictional force is equal to mu Rn1 is equal to 0.25. So friction between the block 1 is the 0.25, okay, 0.25 into 220.75 cos theta. See F1 is equal to 55.18 cos theta Newton, okay. So next the sum of horizontal forces equal to 0. So horizontal force is a T, is on a horizontal force T. Next F1 is the forward force is positive, forward force is positive, backward force is negative, upward force is positive, downward force is negative, okay. Is so T is forward positive, F1 is positive. So is the downward force, okay, backward force 220.75, so minus of 220.75 sin theta is equal to 0. So next on the T, okay, T F1 I'll find it, okay, F1 is equal to 55.18 cos theta minus 220.75 sin theta is equal to 0. This is the equation 1 for block 1, okay. Next for block 2, okay, block 2 is the free body diagram of 14 kg, is the mass M2 is a 14 kg. So is the weight of the block is 14 into 9.8 is 137.34 Newton acting. Is the component force of this one is the clockwise, okay. So component force is anti-clockwise direction. So 137.35. So opposite side is sin theta. So adjacent side is cos theta. 137.34 cos theta. This one. Next for reaction force acting upward, okay, opposite to the weight. So Rn2 is the tensile force, okay, tension in the rope. So opposite direction of friction is the frictional force, okay. This restrict the frictional forces, restrict the downward movement of the block, okay. This is the purpose of friction. So to find the equilibrium of bodies, to sum of vertical forces equal to 0 in this Rn2. So vertical two vertical forces, this Rn2 and 137.34 cos theta. So Rn2 is equal to 137.34 cos theta is the vertical force. So frictional force is F2 is equal to mu Rn2. So friction between the block is 0.5, okay, 0.5 into 137.34 cos theta Newton, so is equal to 68.67 cos theta Newton, okay. Next the sum of horizontal force is equal to 0 find out pannom. So this is the horizontal force is F1 is the horizontal, F2, okay, is the one horizontal force, forward force is a positive, okay. So next one is 137 is the backward, okay, is the minus of 137.34 sin theta is the backward is the minus, also minus, okay, is equal to 0. So F2 already find out, so 68.67 cos theta minus 137.34 sin theta minus t is equal to 0. This is equation 2, okay. This is the equation 2. Already the equation is t plus 58.18 cos theta minus 220.72 sin theta is equal to 0. This is the equation 1 for block 1, okay. Using this equation, okay, so t, okay, minus t and minus t cancel, okay, this is the cancel, okay. So 123.8 cos theta, okay, so plus adding, so 68.61 cos theta plus 55.18 cos theta is equal to 123.85 cos theta. Another one is minus sign, so 137.34 minus 220, so minus 358.07 sin theta is equal to 0. So sin by cos is equal to tan theta, so tan theta is equal to 0.346, okay. So theta of tan inverse of 0.346 is 19.079 degree, okay, theta So substitute the theta is equal to the equation 1 or 2. Okay, substitute the theta value to the equation 1 or 2, you can get the tension in the rope. Okay, this is the problem. Okay, this is the friction and angle of friction problem. Thank you.